Today's session is led by 3 alumni of the Fulbright program and is another in a series of virtual programs that we call our speaker series. In India, the month of June marks the end of the hot summer months and the onset of stormy weather, thunderstorms, and heavy rains. I understand that there is a lot of excitement and relief with citizens eagerly monitoring weather forecasts as they discuss the onset of the monsoon rains. Rainfall conjures a lot of images in our minds. On the positive side of cheer, renewal, plenty, prosperity, or depending on the year and the season, the lack of it, disappointment, anguish, anxiety, failed harvests, drought. So why are monsoonal rains so important? How does it impact the average person, farmers, and even a whole country's economy? And what crucial role do oceans play in this phenomenon? What happens below the innocuous surface of the waves that we see on the sea? In this context, and speaking of water, I would like to briefly mention the ongoing Water Matters project that was organized by the U.S. Consulate General. Water Matters has included 2 Smithsonian curated public exhibitions, a professional fellowship, visits to India by U.S. water experts, a virtual secondary school curriculum, public-private partnerships, and a media campaign. So we recognize the importance of water at the consulate, and this is reflected in some of our priority programs. Turning back to today's topic, to explain these interesting and intriguing phenomena, we have a special guest today from the Ministry of Earth Sciences, Government of India, and 3 Fulbright alumni who will speak about the oceans, land, and atmosphere and their interplay regarding the monsoons in the context of the subcontinent. They will also discuss US and Indian research collaboration in this area. I am delighted to introduce Dr. M. Rajeevan, Secretary to the Government of India at the Ministry of Earth Sciences in New Delhi, who has taken time from his very busy schedule to be with us today. We are very happy to have you with us, sir. Dr. Rajeevan has more than 35 years of experience and is renowned for his research work on tropical meteorology that includes monsoon variability, seasonal monsoon forecasts, cloud radiation interaction, and the prediction of convective weather systems. He has contributed significantly toward the development of many application tools and monsoon prediction models. Apart from being an esteemed member of the Fellow of various National Academies of Science in India, Dr. Rajeevan is a high-level advisor and member of the Research Board of the World Meteorological Organization, which is a specialized agency of the United Nations whose mandate covers weather, climate, and water resources. Dr. Rajeevan, welcome. To start, I would like to ask you, sir, I understand that your ministry has brought in a lot of changes in the prediction of weather and monsoons during the past decade. So can you tell us, what are some of these changes and what do you see as the way forward? Dr. Rajeevan, over to you.
Thank you very much. And so good afternoon and good morning to all of you. And Mr. Moulik Berkana, Cultural Affairs Officer, U.S. Consulate Office in Chennai, Dr. Amit Tandon, my colleague, Dr. Venkatesan, Dr. Shikha Singh. I'm extremely happy to participate in this webinar on the oceans and the monsoon. And as Moulik was mentioning, that monsoon is very important to our country, India. And today we have brought monsoon to Delhi, the capital city of India. Monsoon is progressing this year. Monsoon is progressing very well as we expected, and we have given a seasonal forecast that we have a slight normal to above normal monsoon this year. Hopefully, we will have a good monsoon which should really help Indian agriculture and as well as Indian economy. As we know that India is blessed with the two monsoons, a summer monsoon, so-called southwest monsoon, and a winter monsoon called northeast monsoon. Summer monsoon accounts about 70 to 90% of annual rainfall in the country, and it influences agricultural activity and production of kharif crops, and also Indian economy. That's very important. Indian monsoon is considered to influence Indian economy, especially the major droughts. For example, a major monsoon drought can pull down the Indian economy GDP by almost 2%. Indian subcontinent is surrounded by the oceans. The oceans have large influence on monsoon variability on time scales ranging or starting from synoptic to intra-seasonal, intra-annual, and even in decadal time scales. On synoptic and intra-seasonal time scale, Indian Ocean plays an important role, especially the Bay of Bengal, in triggering and modulating convection over the Indian subcontinent. The so-called active break monsoon cycle of the Indian monsoon is modulated by convection over North Bay of Bengal, as well as the convection over the equatorial Indian Ocean. On intra-annual time scale, year-to-year time scale, the equatorial Pacific plays an important role. The El Nino and Southern Oscillation, so-called ENSO phenomena, has a significant influence on Indian monsoon variability. Many large-scale droughts occurred over India are associated with El Nino. The recent one was 2015, which was associated with El Nino. Thanks to good observations as well as model simulation, especially coupled model simulations, we have a fair degree of understanding how El Nino and monsoon behave, and also the relationship between El Nino and monsoon. However, there are still some gap areas on this relationship which we need to really address. In addition to El Nino and Pacific influence, the Indian Ocean dipole over the Indian Ocean and equatorial Indian Ocean oscillation is called ECHINO, are also known to influence Indian monsoon on intra-annual time scale. However, this relationship is not well understood compared to the El Nino influence. Moreover, the coupled climate models also show large errors in predicting the relationship between Indian monsoon and the equatorial Indian Ocean anomalies. So we need to really understand more about Indian Ocean. Some recent studies have shown some interesting results on linking even the equatorial Atlantic Ocean and Indian monsoon via so-called Atlantic El Nino events. We need to understand more on this new relationship which we have found out. On decadal time scale, the Pacific Ocean plays an important role. Both ENSO and Pacific decadal oscillation play an important role. India is now using coupled climate models. Mr. Moulik was asking what we have done for improving weather forecast and climate predictions. Last many years, last few years, last 7-8 years, we have been investing a lot in improving our weather prediction and climate prediction system. We had good active collaboration with US, especially with the NOVA, NSEP, and also we had good collaboration with the UK scientists. With these collaborative projects, we could establish beautiful prediction the realistic real-time prediction system for both seasonal, extended range, also the short-time time scales. So we could establish this prediction system, real-time prediction system, with the help from both from NSEP as well as UK. And these models are being used for predicting on different time scale, both from weather and to climate time scale. And India is now, as I mentioned, that using climate coupled models for predicting weather and climate over the Indian region on extended range to the seasonal time scales. These models showed reasonable accuracy in predicting these variabilities. We have just started developing a decadal prediction system, which is not available in India, based on a coupled model for the Indian region. We hope that it will be made operational in another couple of years. By recognizing the importance of the oceans, India also involved in many observational campaigns. And right from the first Indian Ocean experiment in 1960s, then many new campaigns like Bay of Bengal experiment called BOMAX and Arabian Sea experiment called ARMAX were conducted very successfully by Indian scientists. Very recently, we have launched the second phase of the Indian Ocean experiment, which is really going on. This observational campaigns produced many new insights into monsoon dynamics and also our knowledge and capability to predict monsoons. In the recent years, under the monsoon mission, India and US joined together and conducted an elaborate observational campaign to understand the mixing process over the North Bay of Bengal, which is very, very important for understanding, especially the monsoon break, active break cycle of Indian monsoon. Later, India and UK scientists also worked together on an observational campaign in the Bay of Bengal again to understand the air-sea interaction process. I am aware that some discussions are going on at present to initiate a new Indo-US joint study to understand the Arabian Sea dynamics and its links to Indian monsoon. Probably Dr. Amit may like to discuss this issue in his lecture today. Indian government also is investing hugely on observational programs over the Indian Ocean. We need a lot of ocean observations to understand how oceans behave and how oceans influence Indian monsoon. So we have put a lot of data buoys, and we recently put a fluxed mode buoy in our Bay of Bengal with the help from, again, US scientists, and many Argo floats are being installed. And so Dr. Venkatesan will talk more details about our Indian Ocean observational program. So oceans are very important to us, and we need to invest more on ocean research, which may include new observations and joint collaborative studies. We are going to launch a deep ocean mission in which we will be emphasizing more on ocean technology as well as deep ocean observations. So we are, Indian government is well aware about the importance, our Ministry of Science is well aware about the importance of oceans and how much we should invest more on research and also join collaborative programs on oceans. So we look forward for more and more joint studies between India and the United States to understand the surrounding oceans, which will help us to predict monsoon more accurately. With this, I'd like to stop here and wish you all the best for the lectures being followed by Dr. Amit Tandon as well as Dr. Venkatesan and Shikha. Thank you very much.
Well, thank you, Dr. Rajeevan, for your very insightful talk. I think that you've set the tone well for the sessions to follow, and it was very fascinating for me to hear about some of the research that your organization has done. I learned a lot, and I'm sure our viewers and followers did as well. And I look forward to hearing from our other speakers today. At this time, I would like to hand over the platform to Lalita from the United States India Educational Foundation and to take it from here. So over to you, Lalita.
Thank you, Moulik, and thank you, Dr. Rajeevan, for sparing the time to be with us today. Good afternoon, everyone. My name is Lalita Nageshwari, and I'm the Program Manager from the US India Educational Foundation in Chennai. The coming together of three Fulbright alumni today reminds me of what Senator William Fulbright said in one of his speeches, and I quote, "Of all the joint ventures in which we might engage, the most productive, in my view, is educational exchange." The Fulbright program aims to make the benefits of American culture and technology available to the world and to enrich American life by exposing it to the science and art of many societies. This cannot be more true than in the case of the three speakers we have today: Dr. Venkatesan from the National Institute of Ocean Technology, Dr. Amit Tandon, Professor from the University of Massachusetts, and Ms. Shikha Singh from the Indian Institute of Tropical Meteorology. Before I introduce the first speaker, Dr. Venkatesan, I would like to inform the viewers here today that we will be having an interactive question and answer session at the end of the discussions. So we urge you to post your questions, addressing it to the particular speaker who you want a response from, and we will ask them, the experts, to address the questions at the end of the sessions. Going over to Dr. Venkatesan. Dr. Venkatesan is scientist and head Ocean Observation Systems, National Institute of Ocean Technology in Chennai, and the 2019-2020 Fulbright-Nehru Academic and Professional Excellence Scholar to the University of Massachusetts, Dartmouth. He is also the chair of Global Ocean Observation Systems Regional Alliance of Intergovernmental Oceanographic Commission. Among the many awards that have won him national and international recognition, the latest feather in his illustrious cap is his nomination as Vice Chair of the Study Group on Ocean Observations and Infrastructure Systems in the World Meteorological Organization in Geneva. With that, I leave the platform to you, Dr. Venkatesan.
Thank you, Lalita. So at the outset, I thank USIEF and Mr. Moulik and Mr. Sudarshan and all others for making this to happen. All these arrangements have happened in a very short notice, and we are very glad from the Fulbright alumni that we are able to talk to you about about ocean science and our interaction. In fact, I had worked with Dr. Amit Tandon in U.S.A, and our interaction was very helpful. Today, I'll be presenting more about real-time ocean data collection. You see the pictures of my interaction during my visit to US under the Fulbright Fellowship. I could visit about 5 institutions and gave about 7 lectures, and that was really interesting experience to interact with experts and to learn a lot. Next slide. So we all know about Indian Ocean where we live. Indian Ocean is important because of the food, water, trade, and energy. And all this depends on the Indian Ocean rim countries. There are about 22 countries in the ocean, and 1/3 of the mankind is living along this and depending on this ocean. And they depend on extreme weather, climate change, and there is a need to understand about what is the importance of the ocean, and monsoonal events and ocean currents play a vital role. And if you look at the picture, the major trade goes through this region. And further, if you look at the northern Indian Ocean, we call it where we live, there are 2 components of Arabian Sea and Bay of Bengal, and we are very peculiar about the monsoon. The word monsoon came from the Arabic word called mausam, and for a common man, it is nothing but raining during the rainy days. And we know very well about Halley Comet. He had quoted about 300 years ago about the trade winds and monsoon in this region, and he has also brought out that time that there could be a differential heating between the land and the ocean that could be responsible for the monsoon. Of course, now a lot of research have gone and various theories and understanding have come forward. And if you look at these 2 oceans, an Arabian Sea and Bay of Bengal close to us, and Bay of Bengal has got about 4 times more cyclones than Arabian Sea, and there is a more amount of salinity in Arabian Sea. There is a large amount of freshwater influx in Bay of Bengal. So that leads to the stratification, and there is an importance to study these Bay of Bengal waters where India and US came together for an important program. I'll mention about that. Next slide. And in order to understand these, next slide, in order to understand these activities, Government of India thought about importance of observing the ocean, that is collecting the real-time data. Way back in 1997, previous slide, way back in 1997, they started a program called Ocean Observation System, wherein a first data buoy was launched, and subsequently we have grown. There are a lot of autonomous instruments which our ministry has undertaken it. We have profiling floats, fixed floats, and drifting floats, and all these autonomous tools collect data and transmit in real-time mode. We are also committed to provide this data in real-time mode in a GTS format through our Indian Meteorology Department to World Meteorological Organization. That gets into the model. That is our commitment. And you can see here the picture of the mode buoy system alone. From a simple 12 mode buoy, we have grown so big and so many observations we are having, and I will discuss about the importance of this. One among them is to have a program with NOAA, where NOAA found an importance to have such observation, which is linked to the society. So they have deployed about 25 moorings, and recently they've expanded 3 more moorings in Arabian Sea. These systems are state-of-art instruments to measure various oceanographic parameters, and all these instruments are maintained jointly by Indian and US team. And we, our secretary, Dr. Rajeevan, has launched a new activity called Omni Rama Network. This is because this network is called RAMA Rama, and these data sets will be made available for others to use. Presently, I can see more researchers are using these data sets and they are getting benefit out of that. In addition to that, we also had an Indo-US collaborative program, which our secretary recently mentioned about it, in Bay of Bengal, where there are about 25 institutions from India and US came together, and there was a campaign mode data collection using the modern tools, and the ships, even 2 ships came together for a particular period. This led to a lot of capacity building exercise and more understanding about this, and that data sets, voluminous data sets are being studied. Next slide. We also got an observatory in Arctic. The importance of having the observation is Arctic to understand about the linkage between our waters and the Arctic. Next, When you talk about observation, it's not only the in-situ observation from the ocean, the satellite play a major role. The satellites gives a spatial coverage. All other observations are about point measurements. And this spatial coverage from the satellite using radiometers, and that has really opened up a newer topic and our understanding about this. And in INSAT, Indian satellites are really playing a vital role. They are backbone of our forecasting systems and our modeling. And when you talk about satellite data, we need to understand about the validation of this data. So our ministry and ISRO have joined together and established a Caldwell station, that is calibration validation exercise. That gives an authentication of the data product, what is being provided is correct. So this specially designed system is installed and we are providing this data in a continuous mode. You can see a long-term data collection being shared and that is being validated, and these products are being made available by SAC ISRO. Next slide. So when you talk about, next slide, when you talk about observation, we need to have a proper reception facility. It's not only the deployment, and we need to have these data sets properly archived and the quality control need to be checked. So we have this state-of-art reception facility. Recently, we have established a very global tier data standard set up, and we have got a redundancy. The data sets are shared with our institute and the system institute in Incois, and that helps us to analyze our system very well. Even during the COVID pandemic period, we had these stations manned 24/7 and 365 days. That is an importance of this commitment. Not only that, when you provide a quality data, we need to understand about the sensor being used and the calibration. Everything you name it is being brought into this system. It is developed in-house by my own colleagues in our institute. So that you can see, seeing is believing. When the system works at sea, we can see in real-time mode how these data sets are being received. We also have subsurface measurement. Not only the surface measurements, up to 500 meter water depth, we measure the conductivity and temperature as well as the underwater current. All these data sets are transmitted once in 3 hours, 8 times a day in the real-time mode that is being received. We also have got a tsunami warning system, so buoy systems that also provide these data to the same center. Next slide. And we also have got a mobile app. If somebody is interested to see, we can see in Google site called iMoon, we can download the data. When you talk about the monsoon, we have strategically positioned with the National Expert Committee. These buoy systems are installed far away from the ocean. Before the onset of monsoon, which reaches to the shore, we were able to capture these signatures. You can see very clearly, well ahead, we were able to have the high wind speed. There is an increase in the wave height. There's a drop in the pressure. All these things are recorded, and these data sets are being real-time used in the model. That's why our prediction and the errors have been improved a lot, and that's the main purpose of these monsoonal events. We also know that this monsoon play a major role for our economy and agriculture. Unless these predictions are being properly provided, that will be very difficult for us. That's the importance to have these observatory strategically located in a different part of the ocean. Next slide. And these systems have withstood, and I will also present to you about two recent experience on the success of having this observatory and trying to understand about the ocean. We all know that the super cyclone Amphan, which has hit the West Bengal coast, and I'm very glad to say that Government of India and Indian Meteorology Department, our ministry and the institutes have come forward and have a perfect prediction as mentioned by our secretary, and that has really helped us to evacuate the people compared to the previous cyclone which happened back in 1997, where the large amount of casualties. We were able to reduce it mainly because of different type of these observation tools and our understanding and also our modeling capability and prediction and expertise developed and so on. Here in this mood buoy system, when the cyclone had crossed to the cyclone landfall was about 1920th May, but way back in 12th May itself, we were able to get the signatures from these systems which were located at sea. So it was mentioned by the Director General of Indian Meteorology Department in one of his lecture. Yes, they were able to give the inversion of the data and able to have the satellite data validation by having these observatory. We also provide the heat potential. It's not only the surface temperature which is important. The heat potential need to be provided in the model that will help us to give the proper prediction. So we can see along the track in one of the location I can say BD13, the cyclone was very close, and the system remained at sea and provided. It's not only the atmospheric condition, there is also subsurface changes taking place that now we are understanding. What is the translational speed, how fast this has moved, what are the changes in the temperature and heat budget this has affected. So having these measurements even subsurface is helping us to understand post cyclone what could be the reason how this has moved. So these are all the way we are trying to understand the nature, and that will help us in the future prediction also. In one of the methodology what we have adopted, which is patented, is called rapid mode data collection. I've shown it in the left bottom, which has been published in the World Meteorological Organization website, to have when the system is moving, when there is a low pressure and high wind speed, the mode buoy system automatically switches over to the rapid mode and start providing the continuous data. Next slide. Next, before concluding, I thought I will show about next another cyclone. We were put in a hardship to have these forecasts back to back, wherein 20th May we had this, subsequently on 3rd June we had the Nisarga cyclone coming in the Arabian Sea. It's very peculiar. Normally we don't find such activities in Arabian Sea, but we had these observatories again helping us to provide this information, even though they were slightly far away from the track, but the information gathered and provided were very helpful. And that is really one of the reasons could be our prediction by the Indian Meteorology Department was perfect to have the proper landfall. Next slide. Next slide. Yeah, this is in a nutshell to say that these type of observations are very important, that is to have a societal benefit and to have a sustenance of observation, because within the EEZ, exclusive economic zone of this country, the country needs to collect the data. And if you look at in Indian Ocean, there are about 22 countries. Unless these countries come together and start providing this data, our prediction won't be further improvised. So that could be a data sharing exercise and the data interoperability. This is what we are discussing in the United Nations level, in the UNESCO, IOC, as well as the WMO, where how best these data sets could be used. There is also a requirement of cost-effective technology. In future, you have a citizen scientist who will start involving and predicting this. Thanks to Fulbright India Commission for making us to collaborate with the US scientists and develop these activities. Thank you very much.
Thank you so much, Dr. Venkatesan. We learned a little about real-time ocean data collection. Thank you so much again. Once again, let me remind the viewers that when you put in your questions, please mention the name of the speaker so that we can have no confusion about who's going to respond to your query. Thank you so much. Our next speaker is Dr. Amit Tandon, Professor at the Department of Mechanical Engineering, University of Massachusetts, Dartmouth, and a two-time Fulbright Scholar, in 2014 as a Fulbright Specialist, and in 2017-18 as a Fulbright-Nehru Academic and Professional Excellence Scholar, both times at the Indian Institute of Science, Bengaluru, though he did visit a whole lot of other institutions during his time in India as well. Among his various publications, paper presentations, and professional and research awards, what is important to mention here is that Dr. Tandon is Chief Scientist of the U.S. Office of Naval Research's Air-Sea Interactions in the Northern Indian Ocean, as well as the monsoon intra-seasonal oscillations in the tropical Indian Ocean and the Bay of Bengal, both research initiatives. And these departmental research initiatives bring together the ocean community from 10 major US research institutions and 9 Indian institutions. Dr. Tandon is also co-chair of the second International Indian Ocean Expedition. Over to you, Dr. Tandon.
Thank you, Lalita. Firstly, I'd like to thank all the attendees for being here. Could we please go to the first slide? Thank you. I would like all the attendees to be here. I see there's more than 400 of you. And I would like to thank USIEF and the Fulbright Association for organizing this webinar. I would like to thank Secretary Dr. Rajeevan for really setting the stage for my talk, and Dr. Venkat and Shikha, who you see on the left-hand side photographed with myself, who both visited UMass Dartmouth on Fulbrights. I would also like to acknowledge the Fulbright Foundation for enhancing the collaborations via their scholar and specialist programs, and especially the Indian Ministry of Earth Sciences for supporting the Indian component of the monsoon-related collaborations through their monsoon mission, including the Ocean Mixing and Monsoons program that you heard from from Dr. Rajeevan. We are next planning US-India collaborations to work on the Arabian Sea international waters in years to come. On the US side, I would like to acknowledge the Office of Naval Research and also NOAA for supporting collaborations in the Indian Ocean via multiple programs. Notably, ONR has supported ASIRI, Mesobob, and NASCAR, which are each 5-year programs in the Bay of Bengal and Arabian Sea. And NOAA has been working almost now for 2 decades with the Ministry of Earth Sciences on Rama moorings in the Bay of Bengal, and recently now in the Arabian Sea. As you see on the left-hand bottom side, a headline from the scientific publication Nature. It says, we've been probing the mysteries of Indian monsoon, or shall I say the remaining mysteries of Indian monsoon. None of this work is possible without a number of scientist-to-scientist collaborations between US and Indian scientists. Almost 10 to a dozen institutions on the US side and similar number of institutions on the Indian team, including the national labs of the Ministry of Earth Sciences, such as NIOT and INCOIS, IITM, and others, and also a number of academic institutions in India, including the Indian Institute of Science and IITs. You see a number of them represented here in the central picture, where you'll see all of us wearing a distinctive red t-shirt in front of the global US research vessel called Sally Ride. This is a photograph from the Chennai harbor in 2019. We're all wearing the same color t-shirt, so we are all part of the same team here, and they're both US and Indian scientists in this photograph. There are many advances we have made in these programs that I talked about, and on the right I'm showing you sort of 2 examples, one of which is a collection of scientific papers in the special issue of the journal Oceanography. Another one is a training workshop, right-hand side bottom, which we held for young scientists from India at NIOT Chennai to commemorate the 25 years of NIOT and also our collaboration. Where monsoons are concerned, we should ask, why do we care about the oceans for the monsoon? Well, it's the ocean that supplies the water for the rains through all of the water that evaporates from the surface of the ocean, forming deep convective cloud systems that form over Bay of Bengal, Arabian Sea, and then move over land. And much of this comes from the Indian Ocean. If you notice the IMD maps showing the monsoon advance, you will notice that it comes through the Bay of Bengal and then onto the Indian landmass in the summer. So the surface of the ocean is very important, both in terms of what sets the sea surface temperature, how the water and the heat move around both on the surface and also the subsurface, as that sets the conditions at the surface of the ocean for the water to evaporate. This is why the cover picture of Oceanography journal shows the atmospheric cloud systems. It shows the interface between the two in the middle picture, and in the bottom it shows the surface waves and the subsurface ocean that impacts the sea surface. Next slide, please. It turns out that the surface of the ocean, where the atmosphere and the ocean meet, is hard to measure because we don't want the instruments to disturb what they're trying to measure. So the ships are very useful for measurements which are below the top 3 meters or about 10 feet. But we have many other instruments that can be deployed from the ship. So in this case, the ship becomes both a research platform from which we are measuring parts of the ocean and the atmosphere, and it also becomes a mothership, a mother observatory from which we can deploy and recover many tools. So I would like to just show you samples, a few of them here. On the left-hand top side, you see 2 gliders, which are very useful because they are probing to the depths of the ocean as they move around. On the right of that, you see a Lagrangian profiler, which can be programmed to follow a particular pressure surface or a density surface in the ocean. Right underneath that, you see surface drifters. These have a drogues on them, and they go wherever the ocean takes them. And as they move, they tell us about where the position is and what the surface conditions are. So that tells us how the surface of the ocean is moving and what its temperature and other characteristics look like. On the left-hand side, you see a mooring, which is very heavily instrumented. This was put together by collaborations with the Woods Hole Oceanographic Institution. It measures a number of air, surface, and ocean parameters, and also has a heavy number of instrumentations underneath it, almost out of 50 instruments to measure all parts of the water column and also measuring the communication between the ocean and the atmosphere. Next to it, you have another glider that measures the ocean mixing and a kaypod that measures the ocean mixing. Let's keep on the previous slide, please. And we also have a kayak, which is heavily instrumented. So the kayak, because it's very much less perturbed by the surface, it almost behaves like another ship, another major instrument that communicates with the ship via radio control. Next slide, please. We also need to measure the atmosphere and the ocean simultaneously. So it is like there's a conversation going on between the ocean and the atmosphere, and we do want to hear both sides of this conversation. We want to peak on the atmospheric side as well as the ocean side. So we also use ships, and on the right, we are even having a Hurricane Hunter aircraft, which we used in 2018 to probe the atmosphere near the ship. The ship at the back that you see is the global research vessel Thompson in 2018. We measure atmosphere through weather balloons and also through radars, through microwave sounders, LiDAR, drones, and a number of weather-related instruments on the front mast of the ship so that they're sampling the undisturbed air. The ship also deploys other floating instruments nearby through chains to measure near-surface properties, and it uses multiple acoustic Doppler profilers to tell us how the water is moving at many different depths. We also deploy instruments that go up and down from the back of the ship. They're called fast CTD because it takes profiles actually very quickly to in the top 200 meters of the ocean as the ship is slowly surveying the surface ocean. Next slide, please. So we've done these measurements of Indian ships as well as US ships, both global research vessels, great observing capabilities. And so far, I've been telling you about what we measure and how we measure it. So I would like to give you two examples of what are the new things we have found so far. There are many scientific findings, and today I have chosen just two to show you so that I can contain it within time. So we knew going into the programs that Bay of Bengal is special. Previous measurements done by Indian scientists, which Dr. Rajeevan referred to, experiments like BobMex and other Indian programs, the Indian mooring program that Venkat talked about, and the space-based sensors from ISRO and other agencies told us that the Bay of Bengal is much less salty than the other oceans, or that it is relatively fresh. What we are able to do now, which is new, is map almost the entire international waters of the Bay of Bengal in very high resolution from a fast CTD-like instrument, both in the vertical and the horizontal. This type of detailed look hadn't been done before, and it is very important for testing our ocean and atmosphere models and for understanding the processes that affect the monsoon. So one feature that you see in the bottom colored picture is the blow up of the top 50 meters or about top 150 feet of the upper ocean in the Bay of Bengal. The top portion shows the temperature spread over more than 600 kilometers, and the bottom panel here shows the saltiness or the salinity of the ocean. So let's look at the bottom picture first, from the right to the left. In the right is where we have South Bay of Bengal, and in the left is where we have the North Bay of Bengal. So as we go from south on the right to north on the left, we are moving from saltier water in the south, which has an Arabian Sea influence, to less salty water, fresher water to the north, which has influence from the rivers and also rain. Remember that fresh water is also lighter, just like warm water is lighter. So a very interesting impact of this freshwater layer is that it allows warm waters to be trapped below the surface on the North Bay. So there's still lighter water on the surface, but the water subsurface can be warmer. You can see this on the top panel where you see darker red colors subsurface in the temperature on the north side of the bay. So this warm water represents extra thermal energy. When a monsoon depression or a cyclone or a storm system forms and goes past a region like this one, this warm water can give an extra kick of strength to the atmosphere, extra energy. It can amplify the convective systems as they move over to the land and leading to higher rain. In other parts of the world, as cyclone systems move north and churn cold waters up, they begin to lose strength. Here in the Bay of Bengal, sometimes this extra heat can sustain or even amplify the storm before it loses strength. So there are unique impacts of this relatively fresh water in the North Bay. And we map these waters in great detail with the accompanying velocity structure, so we know how the water is moving. So these can be used to test and improve our process understanding. And then we can include these improvements in our forecast numerical models to remove the remaining biases. A second picture is shown on the right, and now I'm showing you an example from the atmosphere. The top curve shows the sunlight, so there are 5 days here. So you see on the first day, the sun is shining bright, and then the night comes. The second panel shows the air temperature, which is about 29 degrees Celsius. And the third panel shows the wind speed and direction, which is near 8 to 10 meters per second, and doesn't much change on the first and the second day. On the second day, it's more cloudy, so you see the curve go down. And on the third day, it's almost dark, just like the picture on the top shows. And the sunlight is near zero even during the daytime, so it almost feels like nighttime during the daytime. There are big rain events on the third day. The air gets much cooler by a big drop of almost 5 degrees Celsius, and the wind picks up and fluctuates a whole lot more, and the direction of the wind also goes wild. So we are measuring an atmospheric cold pool event associated with the monsoon convective systems and rain. It turns out that there are over 100 such events at any given place in the North Bay of Bengal. And these cold pools are associated with dry air, and this dry air then leads to increase in evaporation from the ocean. Now, our models and even our satellites don't really resolve these cold pool events, so we need to understand them better, and we need to include them in our predictive models. A combined picture of these processes is shown in a cartoon on the top left. In this cartoon, a monsoon system is moving northward from the South Bay to the North Bay, taking along the convection and the rain with it, and it's being impacted by the ocean structure underneath. We are now beginning to put these puzzle pieces together for the Bay of Bengal for both the atmosphere and the ocean. Next slide, please. Dr. Venkat talked about the importance of observations. In this case, India has deployed Omni moorings, US has deployed Rama moorings, which are shown on the map on the left. The different colors of the moorings are what I'm showing the data from these different moorings. I chose just one particular month from 2018. So this is from May 21st to June 20th, so almost 1 month. In the top panel, we see the sunshine, which is being shifted so that you can see the sunlight at all moorings, including the Rama mooring from US at 15 North and all the Indian moorings from Omni. In the middle panel shows the strength and direction of the wind. So that shows the wind stress, how much force the wind applies on the ocean. And the bottom panel shows the sea surface temperature. So before the monsoon arrives, we have very little wind. The sun shines brightly to almost 1,000 watts per meter squared every day, and the sea surface temperature rises during the day and falls at night. And we see this rhythm in the first part of the May time series. There's a small event around May 29, so the temperature doesn't rise as much. You see an increase in the wind stress and it gets cloudy, and then the ocean surface cools a bit. The event on the June 7th is very much more dramatic. The sunlight is almost cut off by the clouds, which occupy the whole bay, and the winds pick up very strongly from the southwest, and the ocean cools drastically for almost 1 week. And there's a big cooling event of almost 2 degrees Celsius. This is the monsoon onset in 2018 that we also captured from our ship works with both Indian and US scientists. Next slide, please. So the scientists from both countries are now analyzing the results from 2018 experiments and 2019 experiments. We have been going to sea on Indian ships, the Sagar Nidhi, and US ships, Revel and Sally Ride and Thompson, etc., together since 2013. So on the top right-hand side, you see both US and Indian scientists, young scientists, who are standing on the US ship Revel, and in the back you see the magnificent Sagar Nidhi, which is the global research vessel from India. We've had collaboration on board both US and Indian research vessels. We've had Indian scientists on US vessels. We've had US scientists on Indian research vessels. We work together in international waters. We've had float training and deployments. We have glider training and deployments of ocean gliders. We have had training on moorings. We've had junior scientists from India visit various labs in the US. And together with Dr. Venkatesan and others, we have published a really very interesting book on observing the oceans in real time. Here I'm showing you pictures from a workshop on land at Indian Institute of Science in the bottom left. And two other pictures here are from exercises going on the ships, on US ship in the top and the Indian ship at the bottom, with both gliders and the Lagrangian float. These kind of activities are building new indigenous capability for high resolution observations in India, training a new cadre of US scientists well versed in monsoon and air sea interaction, and forging very strong links between the US and Indian institutions. Next slide, please. So in conclusion, we have come to do a number of experiments on the Bay of Bengal and next planning international collaboration on the Arabian Sea side. We have established a long-term observatory to look at the communication between the atmosphere and the ocean. We have done the measurements of mixing rates in the Bay of Bengal to see how that relates to the communication between the atmosphere and the ocean. And we are undergoing right now a number of process observations and modeling to see how to better improve the forecast models as they become more and more high resolution, so that we can set the predictions for both active and break periods and have even better forecasts for the monsoon. Thank you.
Thank you, Dr. Tandon. I think you've managed to capture in a capsule what US-India collaborative observations are about. And this is what the Fulbright is about, I guess, of research interests moving on to become research collaborations, institutional collaborations leading to country collaborations. Thank you again, Dr. Tandon. We will move over to Shikha, the next person, Shikha Singh. Shikha Singh is a scientist at the Indian Institute of Tropical Meteorology, Ministry of Earth Sciences at Pune. She is pursuing her doctoral degree at IIT Mumbai, working on upper ocean physics included in climate models for improving their long-term predictions. She has peer-reviewed publications and has presented her work at various conferences. She is also part of the faculty pool at WMO Training Center of India, Meteorological Department, and the Indian Institute of Tropical Meteorology. Take it away, Shikha.
Thank you, Lalita. Good evening, everyone. It's an honor to be here, and I'm thankful to USIEF for organizing this discussion. I worked for my Fulbright with Professor Amit at UMass Dartmouth, and it was truly an enriching experience for me. For this discussion, I thank Dr. Venkat and Professor Amit for the informative talks and showing how important it is to have a dense network of observations, as well as the international collaborations for development and understanding of physical processes. My background is basically on ocean modeling, and so I'll present the perspective of forecasting on using the models. So the picture which you see here is a satellite image from 2 days ago, which shows cloud bands over the Indian subcontinent. These satellite images are updated on IMD's website every half an hour, and they kind of give you an idea about how are the systems moving. Next slide, please. As Dr. Rajeevan and Dr. Venkatesan said, monsoons have been an integral part of our economy. And so to start off with some background, right back in 1877, when a deficient monsoon was caused due to famine, the government asked IMD to start forecasting. And in 1886, it was the first time when IMD issued a forecast using Himalayan snow cover as the basis. Since then, the relationships between atmospheric and oceanic variables were developed, and statistical models were built to give forecasts and predictions for seasonal scale. They are called the statistical models, but due to the nonlinear relationships and complex feedbacks between the variables, it was not fairly accurate. So informally in 2012, the Ministry of Earth Sciences launched a national monsoon mission where they decided to move from statistical modeling to dynamical prediction system. And for this, there was the climate forecasting system version 2 from NCEP, National Center for Environment Prediction in the United States, and unified model for from UK Met Office was adopted by IMD. There was a collaboration between national and international organizations, and this led to the change from statistical to dynamical system. But before I go into the details of this, let us just understand briefly what a model is. So as you can see on the schematic here, the surface of the globe is divided into 2D array of latitude and longitude. The atmosphere and ocean are further divided into layers, and so this makes it as a 3D array. The Navier-Stokes equation, the basic Navier-Stokes equations are solved on this system of grids in time, and thus the data which we receive is a 4D array. This is a huge network of data, and to understand it and to analyze it, and even to run this model, it is not so easy to run it on a simple computer. And so we need very high computing facilities for this. Next slide, please. Such high computing facilities were not available in the country earlier, and so as a part of the monsoon mission itself, India decided to procure high performance computing power as well. So in 2009 and 10, the first HPC dedicated for climate and weather modeling was procured, which had a speed of 7.2 teraflops per second. And right now in 2018, we have a computing capacity of 6.8 petaflops per second, which is of which 4 petaflops per second is at IITM, which is ranked 53rd in all over the world. So, and India is one of the very few countries to have such a dedicated HPC for weather and climate modeling. Next slide, please. So, as I said a few minutes back, these dynamical systems were adopted from NCEP and UK Met Office. The CFS V2, which was adopted from NCEP, is a coupled system with, which has its own atmosphere, ocean, and land model. A lot of research went into modifying these models to make it suitable for Indian conditions. This was done by validating it through the observations which were present from the past. So if you see the bar graph at the bottom of the page, this shows the hindcast run from 1871 to 2017 for the long range forecast. And if you see the black and blue bars, which the black bar is the observation and the blue bar is the model, it shows that the model has a significantly high skill of predicting the seasonal rainfall. And so this model was, hence this model was adopted. For shorter time scales, if you see to the figure right next to the text, for shorter processes such as cyclones. So this plot shows that the landfall point error, that means the place at which the cyclone makes its landfall, that error used to be as high as 400 to 500 kilometers in 2003 and 4. And now it has reduced to less than 50 kilometers. So we have increased our forecasting capabilities and we have improved on this. The next plot shows that the skill of the systems if we increase the resolution. So if we increase the resolution from the dotted lines here show the resolution for 33 kilometers, whereas the solid lines show the resolution for 12.5 kilometers. So if we change the resolution from 33 kilometers to 12.5, the skill of day 5 becomes equal to the skill of day 3, which means that we kind of gain 2 days. We have a benefit of 2 days by increasing this resolution. And here I would like to point that India is running these models at a very, very high resolution. For seasonal scale, it is running them as high as 38 kilometers, whereas for short range, it is running it for 12.5 kilometers, which is one of the highest resolutions across the world. ECMWF runs it for 9 kilometers for a deterministic forecast. Next slide, please. The short range forecasts are issued for 3 to 5 days. So these forecasts are done by using only the atmospheric component of the coupled model. These atmospheric component is prescribed with near real-time SSTs, and then the model is run. The figure here shows the forecast done using the initial conditions of 23rd June for 24th and 25th. So the figure on the right is for the forecast for today, which shows the rain bands in the north to northeast of the country, as well as in southwest and southern part of the country. So if you remember the satellite image which was shown on the first slide itself, there is a correlation between the cloud bands on that slide as on that satellite image as well as on this short range forecast. So this is very useful for 3 to 5 days forecasting. The recent cyclones which came, for the super cyclone Amphan which came in Bay of Bengal and Nisarg in Arabian Sea, were very accurately predicted by the short range forecasting. The time of the track of the cyclone, the landfall location of the cyclone, as well as the time of landfall was predicted almost perfectly. And as I said before, if we have increased resolution, we gain time from it. So if we have that extra time, it helps the government to plan for evacuation drives or any such preventive measures. Hence, it is very important to have a very good short range forecasting capability. Next slide, please. The extended range forecasts are valid for 10 days to a month. These are used to predict the active and break cycles in the season. So it is important to have the prediction for active and break spells because this is used for agricultural planning or industrial planning and for many other such purposes. The figure here shows the precipitation band, precipitation forecast made for this region based on initial condition of June 17th. And the forecast here shows is for today, valid for today. So if you remember the previous picture and this picture, the maximum rain zones are located almost in the same places. There's a slight discrepancy because here it shows some rain in the central India as well. But the maximum rain zones are located in the same places. And if we look at to the picture on the right, this shows using NCEP forecast. So this the one on the left is done using ensembles of the model, and so is a multi-model ensemble. Whereas the one on the right here shows with CFS. So that picture is done is the forecast used forecast with initial conditions of 19th June, which shows the regions of maximum rain. Maximum rain. So we can see some regions in the northeast as well as southwest, and this is issued for 2 weeks. So for the current week and for the next week. Next slide, please. And finally, the seasonal range or seasonal or long range forecast. So this is for the entire season. This seasonal range is issued for the seasonal forecast is issued for the entire season. The picture on the left shows the cumulative rainfall for July, August, and September. And the green, if we look at India, there is a green color there, and comparing it with the label bar, the rainfall over India is more or less normal for this July to September season. The picture on the right shows the picture from SASCOF, which is South Asian Climate Outlook Forum. So it is basically a consensus of all the models across the world. So the models from US, UK, Europe, Australia, Japan, and all the such countries are taken, and a consensus from them is built upon. And this also shows, this is in agreement with what we get from CFS, that there will be normal to near normal monsoon this year. Next slide, please. So if we look at the onset dates, here is the map from IMD, which shows how is the monsoon progressing. And this shows the green lines show the actual monsoon onset path for this year, whereas the red lines are the mean or normal paths with dates. And as we can see that the monsoon is progressing as expected. It's a normal monsoon year. It is expected to have 103% of the mean rainfall in July for July's mean, and 97% of the mean of September's rainfall in September. As Dr. Venkat and Professor Amit and Dr. Rajeevan said that the conditions in the ocean are very important for the monsoon. So right now, the conditions in the Pacific Ocean, El Nino Southern Oscillation, and the conditions in Indian Ocean dipole, both look neutral. So they are currently in their neutral phases. Next slide, please. Thus, as we all, so this was repeated quite a few times throughout the discussion, that Indian monsoon drives a major portion of our economy. And so it is very important to have accurate forecasts. India has now built up a robust forecasting system with dynamical predictions and supercomputing power. Before this system, the correlation between forecasted rainfall and observed rainfall was around 0.4. But after the dynamical prediction system came in, this increased to 0.6, which is very good. And so seamless predictions are now possible on all time scales from short range to seasonal range. High resolution also helps in improving the model and in reducing the errors, but it is not so simple. It means including all the more physics into the model. So as Professor Amit was saying, that if we have a lot of data, if we have a lot of high resolution data, that will help us to have high resolution modeling as well. So at the same time, taking continuous data monitoring is also required for this high resolution modeling, as Dr. Venkat group is doing. Taking observations in certain intense conditions, like Professor Amit and the entire, all the experiments which have been conducted, they are also important for improved physical understanding, because if we understand the process better, we will be able to parameterize it better and resolve it better in the models. Higher data is always a boon for modeling. It helps us to tune the model to make it more suitable, thus making them more powerful. Thank you.
Thank you so much, Shika. Thank you for the forecast models of monsoons and for also telling us the good news that 2020 is going to be a normal monsoon. We will go on to the next part of the session, which is question and answers. I read out the questions and I'll address it to the person that it has to go to. In fact, we've already had a couple of questions coming through emails this afternoon, so I will start with those that came and then go on to the online questions. So just a couple. The first one is from Dr. Prem Kumar, who asks why there is a change in cyclone patterns over the Arabian Sea in the last few years, and is it attributable to the global climate or any other factors are noted? And a related question from Agni Bandopadhyay, who says, what is the reason for surge in the occurrence of cyclones in the Bay of Bengal region? Is it global warming a dominant reason for such frequent occurrences? This is for Dr. Venkatesan.
Yeah, what rightly pointed out is one of the reasons is we know very well Indian Ocean is getting warmer by another 0.5 degree. So these are all the important points what we come to know during this observation. That is really helping us in a long-term basis what changes are taking place. And we can see really even the tropical cyclone, the pre-monsoon cyclone, what we have seen really how the energy level has picked up and how fast it has moved. Again, the observation is helping us to understand what was the case last year, previous years, and how the cyclone track has moved, because it's energy and movement of the cyclone. These two parts is very important. Here, the ocean really plays a major role. That's how the energy level is increasing, how that is moving forward to that. Because there could be many other low pressure formation which doesn't come to the shore. We may not be noticing that, but here are the case where the energy level is very high. This is what the AC interaction is playing a major role. And Dr. Amit also will add to me that we are working on a very complex system. Even the whole Earth system is complex. In addition to that, Bay of Bengal is much more complex. It can come to your mind that why all along the way the US scientists are coming and working here. It's because large amount of freshwater influx. This freshwater influx is creating a stratification. That stratification, we all know that simply that the heat comes from the sun and it gets heated up and the warming takes place. And this is the simple process what we studied in the school is getting complicated by having this stratification. This is what the science has to say in the long-term basis. Yes, there is a change. We are looking at it. Thank you.
Thank you. A question for Dr. Amit Tandon. Is there any relationship between higher frequency of cyclones in the Bay of Bengal and salinity?
Yeah, that's what we would call in the US $1 million question. So there is certainly, as I was referring to in my talk, there is certainly a very indirect but important impact of the salinity. So when you have more fresh water flow into the Bay of Bengal, that increases the stratification, and the thinner this layer, the easier it is for the warmth to get trapped underneath. So what that is doing is that's leading to a reservoir of heat, which can be bigger. So yes, there is an interaction between the energy which is available to the cyclones and the impact of salinity on the energy that's available to the cyclones. Now, whether there is a connection between the frequency of the cyclones, the genesis of the cyclones, that's a very interesting and complicated process. So there are many moorings, for example, that Omni Rama network that I talked about. So Ministry of Earth Sciences has a number of moorings. Dr. Venkat leads that program from NIOT. There are Rama moorings from the US, which are collaboratively maintained by the Ministry of Earth Sciences and NOAA. There are the kinds of process experiments I talked about. All of these are geared towards answering such questions of saying, what is it that we can predict in the very short term, as Shikha talked about it, in terms of let's say a 5-day lead or a 7-day lead. But we would also like to know what it would be like 2 weeks from now, or a month from now, or a few years from now. And all of these data plus modeling plus observations and the analysis that goes into it is geared towards answering such questions. Thank you.
Thank you, Dr. Tandon. A question for Shikha. What satellite products, sensor or satellite names are used for forecast modeling?
Okay. So a lot of satellite products and as well as data from the buoys go into this forecasting models for calculating the initial conditions. And apart from the satellite, satellite data, which is from India, the data from US satellites and is also used. And so there is a data assimilation group which works at INCOIS, and it combines all that data together and makes it good enough. Good enough to be fed into the model, so that the model can use it to run. To run and to give us the forecast. So it is made so the data assimilation group basically converts it into a compatible format. Thank you.
Shikha, this is not addressed to anyone in particular. Can changes in other oceans like the Atlantic or Pacific affect the Indian monsoon?
The answer is yes. Dr. Rajeevan talked about it in his introduction, and I'd like to sort of go back to a couple of the points that Dr. Rajeevan made. So on an interannual basis, there are changes like El Nino Southern Oscillation, or ENSO, that he talked about. And it's well known that those El Nino versus La Nina conditions have an impact on the all India rainfall. But it's not always a one-to-one relationship. There is statistically we can see that there is a correlation, but there are many other factors that come into play. So the conditions certainly in the equatorial Pacific make a difference here. The conditions in the Atlantic also make a difference here, which was a new connection that Dr. Rajeevan also pointed to. And certainly the equatorial Indian Ocean conditions and the SSTs in the equatorial ocean also have an impact on the monsoon. I would also like to talk about the back impact, and this is one of the reasons why people in the US should care about the monsoons too, because we live in a globally interconnected system. So if we do a poor job of forecasting a monsoon, then it ends up our predictability on a 7 to 10 day time scale here in the US. So if you're interested in enhancing our predictability of the conditions, of the weather conditions here in the US, over and above 3 to 5 day forecasts, then we do need to care about what is happening in the rest of the world, including very strongly the monsoons, because if we can predict the monsoons accurately, then that also helps us forecast it better. So the answer is yes, the other oceans do impact. And there have even been some studies over the very long term of connections between the Indian monsoon and the Arctic. And Dr. Venkat talked about that India's mooring program in the Arctic as well. Thank you.
Thank you. Again, to no one in particular, and two combined questions. I'm taking it together. What is the role of the Indian Ocean dipole on the monsoon? And what causes more cyclones in the Bay of Bengal than in the Arabian Sea?
So I will take the Indian Ocean dipole part probably.
Sure.
Yeah, so as you just explained, Professor Amit, there is a relationship between the Indian Ocean dipole and Indian monsoon. It is not one-to-one, just like El Nino Southern Oscillation and the relationship with other ocean basins as well. It is seen that whenever we have a positive Indian Ocean dipole mode, that is when the Western Indian Ocean is warmer than the Eastern Indian Ocean. So if the Western Indian Ocean is warmer than mean and Eastern Indian Ocean is colder than its mean conditions, in that case, we get the rainfall over India is expected to be higher than normal, and just the opposite in case of negative IOD scenario. But again, it is not one-to-one correlation. It is not always true. These things are affected by what is happening in other ocean basins as well. So so if there is an El Nino taking place in the Pacific Ocean, it may have an effect as well. And so all these effects are combined together. That is why the system is so complex to understand, because there are multiple things which are playing at the same time. Thank you.
We'll just take a couple of more questions before we wrap up. This one is for Dr. Amit Tandon. Dr. Amit, in your presentation, you showed a slide of Bay of Bengal where the salinity and temperature showed lower salinity and higher temperatures over the central bay. Reasons for the same?
Yes, so that was from a particular survey that was done in November, December, and there are multiple scales shown in the slide that I talked about. So one of the things that I sort of glossed over and I did not have time to discuss are these swirling masses of water in the ocean called mesoscale eddies. We see a surface impression of them from the satellites through the sea surface height. So we were monitoring that as we were doing these surveys, and we also see their impact subsurface. So some of the scales that you see, so there are very fine scales in the plots I showed, both in the horizontal where things are changing even on a scale of kilometer by kilometer, but there are also changes that are happening over 100 kilometers or so. So that central bay was very strongly impacted by what I would call the mesoscale in the ocean, which are these eddies, which basically stir and mix. It's almost like if you've mixed cake batter and you're stirring something like chocolate into cake batter, you can tell that it's breakfast time here. And then as that batter gets stirred in a similar way, the Bay of Bengal has these mesoscale eddies which are stirring, and you see the influence of that stirring in the graphics that I showed you. Thank you.
That's a language we understood, Amit. Thank you. The last question for Dr. Venkatesan. How do these observations and data being collected, how do you validate them, and how much is it authentic?
Thank you. That's really a tough job because we need to go to the site. Some of them are located very far away. My colleagues, they have to sail at least about 120 days to 150 days in a year, because these systems, when you deploy at sea, they are subjected to wind, waves, cyclones, as well as there is a biological growth and degradation of the material called corrosion, and the deterioration of the sensor, because some of the sensors may not be working in a long-term period. So there is a need to go there, pick up service and redeploy them. That's a challenging job. We have a good ships. Thanks to our vessel management cell, we are maintaining a very good ship, because that requires a special dynamic positioning system, because we need to go and deploy the system with a 1 meter accuracy of vessel being kept in one location. So it's a very challenging job involving various people, navigational experts and technician, engineers come together, because we go to the location only once in a year. If you make a mistake, yes, next year only we can go on service. There's a large amount of best practice methods we have evolved. I'm glad to say that we were able to train this experience and expertise, what we have gained in more than 2 decades with others. That is what is a strength, and that is what is a collaboration calls about it. How do you calibrate it? Because when you provide the data, the value means the quality of data is very important. So in fact, Amit talked about the incoming flux, that is a heat flux. So one of the complex data one can talk about. In engineering terminology, it's a microvolt measurement. Any error can give a wrong information. Here comes their expertise, like Consulate Oceanographic Institute. They have dedicated their life and they are working. So they are ready to come forward. That's the best part of the whole thing in the science. You come and help each other, understand what mistakes you have done and what learning you have done. So the whole exercise here is to bring and provide a quality data. That is what we have been doing. We interact with many other countries and UN agencies to bring forward such a quality measure. Thank you. Good question.
Thank you so much. There are a lot more questions from the viewers. We've had an overwhelming response today. We have about 445 participants. We've given the email IDs of USIEF, the American program and the Indian program, and the 3 speakers today. So please post your questions to the resource persons or to us, and we will forward it in turn to them. I'm sorry we don't have enough time to address all the queries. Thank you for the wonderful presentations. As I said earlier, the Fulbright program for all 3 of you has served as a common platform to come together to share your expertise and your shared passion for oceanographic studies and the ocean atmosphere dynamics. I'm going to hand it over to Dr. Diya Dutt, our Deputy Director, for the closing remarks. Over to you, Diya.
Yeah, thank you, Lalita. Dr. Venkatesan, Dr. Tandon, Shikha, thank you so much for an excellent presentation and improving our understanding of a complex monsoon phenomena which impacts all of us, as well as highlighting, the joint work that is happening between US and India. I also take this opportunity to thank Mr. Moulik Berkana, Cultural Affairs Officer, US Consulate General Chennai, and Dr. Rajeevan for their support and their presence throughout the event. Thank you so much. I also want to thank the audience for your engaging and very lively participation. We know that these are very difficult times, and we really appreciate, your participation, because this makes our work so rewarding. As many of you know, 2020 began as a very special year for U.S.A. Educational Foundation as we completed 70 years of the Fulbright program in India. And one of the critical work that we do is to engage our alumni after they complete their grant. And today's event was an example of that effort. I also want to inform everybody that the Fulbright Fellowship application is open for Indian citizens. So please visit our website, usief.org.in, and do log in and send us queries in case you want to apply for the fellowship. So thank you, everybody, once again for making it so rewarding, and it was a pleasure. Thank you. Bye.
Thank you.
Thank you.
Thank you.
Thank you. Thank you. Thank you, Dr. Dutt. Thank you, Mr. Moulik. Thanks, Ms. Lalita, for all the good work you all have done. Thank you very much. Thanks to attendees. Thank you very much.
Thanks
Thank
to
you.
everybody. Bye-bye.
Thank
Bye.
you so much.
Bye-bye.
Thanks to all of you. Bye-bye. Have a good day and have a good evening.
You too.